Bob has designed a truly unique boat that has very impressive benefits. Now, if you've got absolutely bottomless pockets and you don't care how much you spend on fuel, the following might not interest you. But Bob has designed a boat that will cruise at medium speeds, say 8 to 15 knots, very, very economically. He has revolutionized hull design and created a very efficient boat. Now tell me, Bob, what is it that makes this boat so efficient?
Well, let's first look at the three different hull designs, or hull shapes.
Yeah.
And we can start here with a displacement boat. And this is typical displacement lines. You'll find the lines on the bottom of the boat rising as they go aft with a shallow transom.
And coming flatter towards the aft here, yes?
Well, actually they still rise in a displacement boat like this so that they're very shallow at the transom. You get a good flow of water at low speeds.
Right.
But a displacement boat ends up, or any boat, ends up creating a bow wave here and a stern wave here.
And its length and its speed is restricted by its length, is that right?
That's correct.
Yeah.
And that's relative to the size of the boat or the length of the
Right.
boat. So in a boat our size, that'd be about 7 knots.
Right.
And of course, if you tried to increase the speed, you have to drive the boat over the bow wave. And when you do that, you end up with the stern sinking in the trough between the two waves, and that restricts its speed.
Yes. So that is the classic displacement hull.
That's right.
Right.
Now you can overcome that problem to some extent by going to a semi-displacement hull like this one.
Right.
Now what we do with the semi-displacement hull is flatten the after sections here, still keeping a shallow transom, but we still have a rounded bottom. So what it does is this section keeps the stern from squatting.
Right.
But the rounded bottom means we're still pushing a wave with it.
So you're still not overcoming hull speed.
We overcome hull speed, we go a little bit faster, but all we do is keep the stern from sinking. But
Into the trough.
Into the trough.
Right, yes.
But the bow still has the rounded curves here, and so it can't get up on plane, it's just still pushing that wave harder.
Right.
But the stern now doesn't sink, so you can increase the speed slightly, but you can't get it up on plane properly.
Now let's see if I've got this right. With a displacement hull, its speed is limited by its waterline length.
That's right.
And no matter what you do, you can't make it go faster.
Correct.
However, with a semi-displacement hull, you can make it climb up its own bow wave and increase its speed over its theoretical hull speed, but not by very much.
That's right. You're still pushing the bow wave all the time you do it with a semi-displacement hull.
So if you want to go faster than that, what's the next step?
Well, that's the planing hull. Let's have a look at that.
Let's have a look.
So what we do differently here is the bottom lines are parallel to the water line.
Right.
And we have a deeply immersed transom. We have a big cube shape here.
Right.
And that makes a big wave when you try and push it. But if you put lots and lots of power to it, get it up over its own bow wave and skimming on top of the water.
And then the whole hull gets on top.
That's right.
But it takes a lot of power to get it over on top of and over its own bow wave.
That's right. But once you get enough power in there and get it to overcome that wave, then it can skim on top of the water. But as it tries to get up over the wave, the power to get it up over top with that large cubic area is extreme, and it's very inefficient at any speed below about 15 knots because of that.
And even then it's expensive to run.
That's right.
So it takes power, lots of power, to move the boat over its own bow wave. This means bigger engines, more fuel, and more costs.
Yes, it means more costs. Well now, John, supposing we can design a hull that completely eliminates the bow wave.
Eliminates the bow wave? Well, I can see a lot of advantages in that, but how would you do it?
Well, the secret's in the keel form hull.
Keel form hull?
That's right. I'll show you what I mean.
Right.
If you look at the running lines on the bottom of the hull here, you'll find they're still parallel with the water line, like a planing hull.
Right.
But the transom is immersed very shallow, as it is with a displacement hull.
Right.
And the way we get away with that is we take 25% of the volume up from this area and put it in the keel. And we can see that easier if we come over here and have a look at the end view of the keel. And we take that same volume and stretch that out into a long, narrow appendage which we have from here to here,
Right.
then that volume we've put in the keel now is far enough below the waterline where it doesn't make a wave, because the wave is only made at the waterline surface.
So it's two things really then. It's the shape of the keel and the redistribution of the weight below the water surface
That's right.
that eliminates the bow wave.
That's right. The bow wave is eliminated at any speed, so now let's look at the benefit. The first benefit is there's no need for massive extra power to overcome displacement speed. And so the big benefit is when you want to cruise at medium speeds, between 12 and 15 knots for instance, because there is no bow wave, there's no wave to overcome, and the boat just comes up steadily, not like ordinary hulls. The fuel